Hello everyone and welcome to Dual Band Satellite Dish Slot Antenna. My name is Marcel, AI6MS, and this was recorded for the QSO Today Virtual Ham Expo. First, a little bit about myself. My name is Marcel, AI6MS. I was licensed in 2008 as KI6QDJ while I was a student at Cal Poly San Luis Obispo, where I received my master's in electrical engineering with a concentration on RF and communications. I am a volunteer tower climber and RF consultant in my free time, volunteering with Cupertino Aries as a repeater trustee and several other amateur radio clubs and repeater groups. My slides and video from this presentation are available on my QRZ page, and you can reach out to me on Twitter or see other presentations of mine on my YouTube channel linked below. So today's presentation will be going over this improved dual band stealth antenna design for using a satellite TV dish. So we'll go over the background for this antenna design, talk about the design and construction for it, and then finish up with some interesting testing that we did for both SWR and radiation pattern. So first off, why a satellite dish? Well, not everyone can put up a tower or a vertical antenna on their property. I, for one, in my current rental situation, do not have the ability to put up any antennas on the outside of the building. Luckily, there is an exception. In 1996, the FCC released a CFR that has an explicit exclusion preventing HOAs or homeowners associations from blocking people to put up satellite dishes on the outside of their houses. So as a result, in 2016, John Portune W6NBC put together a very unique proposal for a 2-meter antenna disguised as a TV satellite dish. Here's a snapshot of the QST article that he wrote on this topic. So this is a very intriguing design and something that I was really interested in. And my big question was, can we make it dual band? I really wanted to have a way that I could work repeaters in the area and be able to do not just 2-meter operations, but also 70 centimeter. So anytime I start a project like this, I think it's really important to sit down and look at the overall design goals for the project. So in this case, I wanted to use an existing satellite TV dish in order to meet the kind of stealth requirements for being able to put it up. And we'd base it off of John's design, so W6NBC's design. When we're done with it, I'd like to maintain the outward appearance so that it still looks like a satellite TV dish, right? We don't want it to change significantly so that it would stick out. And we'd like it to operate on both bands with better than a 2-to-1 SWR. So that's kind of standard for mobile radio, just making sure that it's relatively functional. Ideally, lower is better, but that would be for the US, VHF, and 70 centimeter repeater band. That's primarily what I was focused on. The other important design goal was a single feed line. So with 2 antennas or 2 bands, I didn't want necessarily 2 separate feed lines. So that was one that we'd have to run through like the house or through the wall. So a single feed line is good. And of course, we'd prefer an omnidirectional pattern, given that I have repeaters in all directions around me. I live in the Bay Area in California. That would be an important part of that criteria as well. So the actual slot design is pretty interesting. A slot antenna is pretty much like a normal quarter wave antenna, except that it's buried inside this dish. So the slot is actually the antenna that's the radiating element. So it's just an inverse antenna. Acts kind of like a dipole, and that's how it works out. Now, the calculations for these came from 2 presentations. So John's article nicely puts this out. The first one is the slot length, where you calculate it using 468 divided by the frequency. And then the actual feed point, which is where the coax connects, is by 936 divided by frequency, and then the weighting factor to get it to inches. So for these, you can see it's a relatively long, almost 39 inches for a 2-meter and about 13 inches for a 70 centimeter. Now, one of the key criteria was how we could fit this all onto the dish. So when I looked at the design, ideally I would have liked to have a single slot with a single feed point, but for the first version of this, we said, okay, we'll do 2 separate slots and pretty much just treat it like 2 separate slot antennas, and then use a diplexer to get the single coax feed. So we treat these as independent slots on the dish, and then just have one piece of coax running to both, and then the diplexer splitting it out. So one of the key things that we were trying to figure out is, okay, how do we place the slots? So here on the left, you can see, we'd put the larger 2-meter slot down below, and then the 70 centimeter slot up above, or we could flip them and have the 70 centimeter slot in the middle and the 2-meter slot above. These were kind of the ideas that I was playing with when I was first looking at placements. John Portune W6NBC actually helped with some strategizing here, and we were thinking about better ways to do this, and we said we'll just try it. So we ended up picking this left one for the first iteration. And one of the key things that we wanted to see when we were done was what the radiation pattern would look like. There was some concern that the placement of the slots next to each other that they would pull, and also how central the antenna is would change the performance of the vertical elevation pattern. So once we decided that, step one is to get a physical dish. Interestingly enough, they're surprisingly easy to get your hands on if you live in a metropolitan area. Craigslist, FreeCycle, Nextdoor, etc. Have them all over the place. Usually you can find them in the free section. This was just pulled up recently from the San Francisco Bay Area free section, and there are 3 dishes, it looks like, that you could pick up within an hour's drive that are free. And if you're willing to pay 20 or 30 bucks, you can get them pretty easily. And of course, ask your neighbors or your radio club mailing lists, or look around for one that's mounted to the side of the house with a cut coax on it. Chances are that they don't want it there, and if you take it down for them, they'll be happy to give it to you. For this particular implementation, we also needed a diplexer. You could buy one new from HRO or DX Engineering for $35 to $70, or find it used, or from a friend or from another ham radio operator that doesn't need it. You could also build one. In my case, I had these PCTEL dual band couplers that I found at a flea market for $1 each, no joke. Great example of walking up to a flea market, knowing what you're seeing, and then getting a great price on it. So I picked up a couple of these a couple of years ago. It's important to check the frequency split. So diplexers are often made for HF and high band, like splitting those out. So you have to make sure that you're getting the right one for what you're trying to do. In this case, this particular one covers both the VHF ham band and the UHF ham band easily. Next up is cutting the slots. So we measured out the slots and put them on the back of the dish, very carefully measuring and marking with a Sharpie, and then dremeling or jigsawing out the actual slots in the metal. The metal's pretty difficult to cut on these, and it does become a little bit floppy because you're messing with the structure of the antenna with this large U-shaped slot. So it is important to kind of just be careful there. One of the things that I did is, and as I've seen this in other designs as well, is adding this support brace here in the middle. This was a temporary one out of wood just to hold the dish and make it a little bit more sturdy. In the bottom left here, we mount the diplexer itself, and that's just mounted with 4 screws onto the back of the dish away from the slot so that it's not interfering with anything in there. Next, add the coax and feed points, again following W6NBC's design with a 1-to-1 current balun, just some turns of coax. This is RG8, and then crimped ring terminals at the end with connections at the feed point based on the calculations we did earlier. So you can see both the feeds here going into the diplexer for the UHF slot up top and the VHF slot down below. Once we hooked it all up, hooked it up to the antenna analyzer. So this is a Rig Expert A600. And you can see the resonant frequency here was a little bit too high. So this one was about 149 megahertz when our target center frequency was around 146, right in the middle of the repeater band. And then on UHF, it was also a little bit high. So this sat around, I think it was around 449 as well, so kind of on the upper end of the repeater band. It was fine for operation, but I wanted to shift that down a little bit. So the easy way to do that on these slot antennas is just cut it a little bit longer. So at the end of the slots here, at the red arrows, you can see we just cut an extra, 1/4 inch and just move it down a little bit. After I did that, you can see that the actual resonance shifted down nicely. So this is nicely pretty much centered on the repeater band for VHF, and similarly for UHF, surprisingly broadband. This is plus or minus 16 megahertz. So this is a 32 megahertz bandwidth, and it's still below 2-to-1 SWR, so that was great. The final lengths here are for anyone that wanted them for their reference, but it really depends on the specifics of your design, exactly where your feed point is. The diplexer probably has an impact, and the proximity of the slots probably has an impact as well. So that's something to think about when you're designing it yourself, or doing one if you're wanting to build one like this. So this is what the final product looked like. You can see I mounted it onto a temporary wooden structure just as I was doing testing and working with it. The slot here, you can clearly see the 2-meter slot at the bottom and the 70 centimeter slot at the top of the dish. The interesting thing here that we'll get to in a little bit is this position for this upper slot is at the very edge of the dish, and that significantly impacts the radiation pattern we found out. So this is a key thing to watch for, and we'll touch on that a little bit later. The other thing to note here is that we did one final coat of gray paint. This dish was already relatively worn, so the DirecTV logo that was on the main dish was already gone pretty much. So a fresh coat of gray paint on the front and back just to kind of make it a little bit more stealth and cover everything up. Looks nice and clean. So the next step was doing some actual radiation pattern testing. We'd done SWR testing, so we know the antenna at least at least absorbs the power and takes it as a good match at those bands. The next thing to do was see how does it actually perform. So this was an interesting test. I waffled back and forth on how we wanted to run this, and I settled on a relatively simple setup. There's a local park that has this nice slope in the middle, a nice little hump or a hill that I was able to put the transmitting dish antenna on top, and then I had a receiving Yagi on a pole on a little mast here at the end with a spectrum analyzer. So you can see that here at the end. That's KK6QFQ, my RF technician for the day. She was manning the spectrum analyzer and had the Yagi antenna pointed up at the dish. And then the dish itself used the RigExpert A600 in SWR measurement mode. So that would put out a signal onto the antenna, and we could then get relative measurements from the spectrum analyzer as we rotated this antenna. Key thing here is documentation, right? So as we did all these tests, very clearly documenting which pieces of test equipment were used where, what our test setup was, what the orientations and references are, so that it's really easy to, when you get out of the field, that you can actually do your calculations properly. So this is what it looked like. This is in the middle of doing an Azimuth test, so we're rotating the antenna clockwise here, taking a measurement, and this is the receive Yagi. I used just a level and then an inclinometer here effectively to get the actual elevation angle of the dish as I moved it around to get different angles and get the full pattern measured. So in this case, I did two sets of measurements. So we did the azimuth measurements where we went around 360 degrees in 30-minute increments using just a clock for reference. So 12 o'clock, 12:30, 1 o'clock, all the way around. Did 360 degrees at both bands, so both UHF and VHF. And then the elevation measurement data was done just in the forward-facing direction. So we don't have side lobes and everything measured, but just in the forward-facing direction, tilting that antenna back and pointing it down as well. So took a number of measurement points here, did a couple intermediate measurement points at 5-degree increments, but most of it was about 10-degree increments. So these results were really, really interesting. The azimuth radiation pattern, so this is lateral as we're rotating around. You can see that it's kind of this figure 8 shaped pattern. As expected, there are some nulls as you reach the the length when you get perpendicular, or sorry, when you get parallel to the plane of the dish itself. There is kind of a null both on VHF and more pronounced on UHF. There's actually quite a big null there on to the side. So if you're using one of these antennas on your roof, where that null is actually kind of important. It could be helpful if you have an interference source, like I actually have nearby, so I could rotate it so that's pointed at the interference source and blocks out those signals. But if you have a repeater in that direction, that could be actually be a problem. It's important to note these measurements are referenced to, they're normalized to the peak of the measurements we took. So this is not a 0 dBi measurement. This is relative to the max. So this was the maximum point. And then the front to back ratio on the VHF is actually interesting. It's slightly better performing to the rear, presumably because the feed arm here gets in the way a little bit. On UHF, it's not much different. It's actually almost exactly the same front to back. So it's just a little interesting to see the different performance here. We also did the elevation pattern, and this one was fascinating. So the actual elevation pattern varies quite a bit, both for VHF and UHF. In both cases, the slot's a little bit above the halfway point. So I put the antenna here to kind of show where that feed point is, or where the radiation point is. So for the VHF antenna, it's a little bit above the midpoint of the dish. And you can see these lobes down towards the bottom, and then there's a little bit of a null, and then it increases back to the top. On UHF, it's much more pronounced. The lobe is actually very strong towards the bottom. That's where your peak is. the lobe towards the top is almost 3 dB down from that. And this is likely due to the placement. John Portune did some simulations of this, which is really interesting. So specific to the UHF slot in that upper position on the dish, we got this very distinct kidney bean shaped pattern, again with the larger lobe down below the horizon, and then the 3 dB down lobe up top, right? And the blue dots here are the measured values that we got, and then I filled in the extrapolated data on the right here so you can see how that matches from the simulation to what we actually measured. And it's really interesting. The simulations match what we measured very closely. It's important to note that this simulation was just to the UHF slot on its own, and the measurement here was with the VHF slot on the dish. The conclusion there then is that the two slots don't really impact each other that much in the setup we had. So that's a nice a nice conclusion to have that helps us with some of the next steps for future versions of this antenna that we might want to design. So lessons learned. The first one is center the slots, right? So this is what we were just talking about. The slot positions you can see on the right with the UHF at the very top, that's what caused that that kidney bean pattern that was really not what we want in the vertical elevation pattern. So by moving that slot to the very center of the dish, or as close to the center as you can, you're going to get a much more even vertical elevation pattern. There'll still be some impact of the feed horn and the feed arm if you're leaving that there, or some people may want to change out that steel feed horn for maybe a fiberglass one so that it's not doesn't impact the pattern as much. But that's the first big lesson learned here, is move those slots down. So we don't necessarily worry as much about the proximity. So the proposal here on the right is actually move both slots closer to the center to get a better vertical pattern. The other thing that I wanted to play with is different feed points. So right now we're using the diplexer just to simplify and the initial design. I would really like to do something with a dual band feed. So two images here on the left are just an example of how this could be done, where you place the actual feed point for both the UHF and VHF right next to each other, so you could just bring the coax in directly to that point and have the coax drive right in the middle there between the two slots. So this would be an interesting one. Now the problem here is, of course, the UHF slot is off-center, so you'd have to play with these a little bit. We haven't simulated these yet to see which would give you better patterns or how the pattern would change. Presumably this lower one would have some issues with the slots being off-centered and down to the side. So depending on which band you want to prioritize as well, you could play with this if you wanted to try a single feed point. Alternately, you could still do like the original design we did with two separate slots, and then do just a Y-coax harness where you have different phased lengths feeding the VHF and the UHF to isolate the two from each other. So that should work in theory, just didn't try it out. So that's pretty much the presentation. I always like to go back to the design goals that we put at the beginning and just see how we did, right? Anytime I start a project, it's kind of important to show what we wanted to do and how we got there. So we used an existing satellite TV dish using W6NBC's design, check, right? The outward appearance of the finished product is pretty similar. We lost the DirecTV logo. Sure, I could paint it back on with black spray paint, but I don't think that's really critical. The 2:1 SWR, we definitely met this. So the antenna is actually quite broadband, so we actually exceeded these specifications. The 70 centimeter one, we have at least a 32 megahertz bandwidth. That's better than 2:1. So that's really quite nice. The single feed line we accomplished with the diplexer, shown here in the bottom left again. Pretty simple way to just get two antennas into one feed line to go back to dual band radio. And then lastly, the omnidirectional pattern. We didn't quite meet that one as much as I'd like. I would have liked to see if there's a way to get the antenna even more omnidirectional, but I think that's largely a limitation of kind of the dish design, and you'll naturally have those nulls off the ends of the slot antenna. Just like with any other antenna, you'll have a null in the direction of the current pattern there. So high level, worked out pretty well. Very happy with this. Throw it on a roof, mount it to a fascia board, and hope your neighbors don't notice. I want to give a special thanks out to John Portune, W6NBC. He was really helpful, his mentorship, guidance, and simulations, and just overall very willing to help with this project. He wrote the original article in 2016 proposing this type of antenna, and I reached out with it to him last year trying to get some guidance on how to design a dual band version of this. So we put a lot of work in that. He helped out with some simulations, and we're excited to see what other people might do with this. Fun fact, John administered my amateur radio technician exam back in 2008 down in Santa Maria, California, is where he gave that exam. So that's all I've got for you today. We'll be sticking around for the Q&A if you're here for the conference. If you're watching this offline or later, you're welcome to reach out to me at my call sign at awrl.net. And I do want to put out a plug for people that are still remote these days. The fully remote amateur radio exams are offered daily through hamstudy.org/sessions. So there are lots of groups doing online exams. So if you're looking to get an upgrade or get yourself licensed or a friend licensed, send them over there and hope to see you there. Thanks to Eric and Rachel and the rest of the group for putting on this event. Have a great day.